Hello, we have already started chapter transmission line and we have finished this topic transmission line parameter, equation of voltage and current on transmission line, propagation constant and characteristic impedance. So today we will discuss about next topic, what do you mean by the lossless and distortionless transmission line, and then after in next lecture we will discuss about input impedance, reflection coefficient and VSWR, voltage standing wave ratio. So in today's lecture we discuss about what do you mean by the lossless transmission line and distortionless transmission line. Okay, so till now we have derived this equation for the transmission line gamma, which is known as propagation constant, which is under root of r plus j omega l g plus j omega c, which is nothing but alpha plus j beta, where alpha is known as attenuation constant and beta is known as phase constant. And next is characteristic impedance, which is under root of r plus j omega l g plus j omega c. Okay, so now in today's lecture we will discuss about lossless and distortionless transmission line. So first, what do you mean by the lossless transmission line? So lossless transmission line is indicate there is no loss, that means no power loss throughout the transmission of electromagnetic wave propagation throughout the line. Okay, so see here, actually we have considered transmission line is nothing but is a two parallel conductor. This one is my first conductor and second conductor, so they are the two parallel conductor which makes a transmission line. RLC is a parameter of the transmission line. Here I have to connect a generator or source, and here it is a load. Okay, so lossless transmission line means there is no power loss throughout the transmission of wave throughout the line. Okay, so it is known as distortionless transmission line. Now here, how the transmission line is made? So transmission line is nothing but is a two parallel conductor. Okay, we have already discussed about it. Transmission line is nothing but is a two parallel conductor. So just I have to simply draw here. So there are the two conductor which are connected in parallel. It's a simple example of transmission line. Okay, first conductor and second conductor. So two conductor are connected in parallel. These two are conductor. Okay, and we know the property of the conductor. What is the conductivity of the conductor? So conductivity of conductor is very high. So we have assumed the conductivity of these two conductor is approximately infinity sigma c. C is stands for conductor, so conductivity of the conductor is very high. Okay, so that is why it is known as the conductor. And the medium between the two conductor is nothing but this medium is dielectric medium. Okay, whatever the medium is present between these two conductor, it is dielectric medium. This medium is known as dielectric medium. Okay, now whether my transmission line is lossless or lossy, it depends on what? It depends on the conductivity of this dielectric medium. It does not depend on the conductivity of the conductor, because these two are the conductor, so it's obvious the conductivity of the conductor is very high. Okay, but if the conductivity of dielectric material is zero, okay, if the conductivity of this dielectric medium is zero or very low, approximately it is zero, so it is known as lossless transmission line. Okay, and what do you, okay, so if the conductivity of this dielectric medium is zero, so it is known as which type of transmission line? Lossless transmission line. And if this conductivity is not zero, it has some finite value, so it is a lossy dielectric medium and the transmission line is lossy transmission line. Okay, so whether your transmission line is lossy or lossless is depend on the conductivity of dielectric medium. It does not depend on the conductivity of conductor. Okay, so first is lossy transmission line. So first we discuss number one, lossy transmission line. Okay, not lossy, lossless. Okay, sorry, it's lossless less transmission line. There is no loss, there is no power loss throughout the propagation of wave. So it's lossless dielectric, okay, or lossless transmission line. Okay, now in last lecture we have also studied about one more thing, that is the parameter of transmission line. So R, L, G, C are known as parameter of transmission line. Okay, so here there are the four parameter of any transmission line, which is resistors, inductor, conductance and capacitance. What do you mean by the resistance and conductance? So this resistance and inductance, these two are offered by the conductor, and conductance and capacitance which is offered by the dielectric medium. Okay, I have to again draw it so you will get the easy concept of it. Okay, so it's very easy. Again I have to draw transmission line. Okay, which are the parameter of the transmission line? There are the four parameter of transmission line: R, L, G, C. Resistor, inductor, conductance and capacitor. Okay, so here resistor is offered by this two conductor, and inductor which is also offered by these two conductor. Okay, and they are known as distributed parameter because they are distributed throughout the line. Okay, and what about the conductance and capacitance? Conductance and capacitance are offered by the dielectric medium. Okay, so here it is not a resistance, this one is my conductance G, it is a conductance G. Okay, and then capacitance, again conductance and capacitance. Okay, so the parameter are distributed in this way. So if you observe where the resistor is present, the resistor is offered by the two parallel conductor, where the conductance G is offered by the dielectric medium. Okay, now what is the equation of the resistor? The general equation of the resistor: R is equals to rho L by A, where rho is known as a resistivity. So it is L upon sigma A. What is sigma? Sigma is conductivity. Okay, conductivity of what? The conductivity of the material. Okay, so resistor is offered by this conductor, these two conductor. Okay, and what is the conductivity of these two conductor? It is infinity. So L upon infinity. So resistance is 0 for lossless transmission line. Clear? Now what? Okay, so this is the first resistor. Second, conductance. We know that the equation of conductance is A upon rho L, which is nothing but it's the inverse of resistance. Okay, so it is sigma A by L. What is the conductivity of this dielectric material for lossless transmission line? The conductivity is 0. So it is 0 into A by L. So it is 0. Okay, so now we will get there are the two conditions for your transmission line should be a lossless. First is value of R should be 0 and value of G is also 0. Okay, so if these conditions are satisfied, so we can say that our transmission line is a lossless transmission line. Otherwise the transmission line is lossy transmission line. Clear? Okay, so whether your transmission line is lossy or lossless is depend on what? Is depend on the conductivity of dielectric medium. Okay, the medium which is present between these two conductor. It does not depend on the conductivity of the conductor, because by default the conductivity of the conductor is very high. Okay, so if you change the dielectric material, the property of the transmission line is changed. Okay, so now I have to put the value of R and G in the equation of propagation constant and characteristics impedance. Okay, so when we can say that the transmission line is a lossless, so if conductance, okay, if the conductor of lines are perfect and dielectric medium separating these two lines is a lossless. Okay, clear? So now I have to put value of R and G into the equation of propagation constant and characteristics impedance. Okay, So first, propagation constant gamma for transmission line is R plus j omega L G plus j omega C. For lossless transmission line, value of R and value of G both are 0. So this j omega L into j omega C. So gamma is equals to j omega under root LC. And what do you mean by the gamma? It is nothing but the addition of real part and imaginary part. Okay, so if you compare these two, so value of alpha is 0 and value of beta is omega under root LC. Okay, value of alpha is 0. And what do you mean by the alpha? Alpha is my attenuation constant. Okay, it's the attenuation of the wave. So there is no attenuation of the wave. Okay, so the wave is not attenuated throughout the transmission. Okay, so why? Because the line is lossless. So what do you mean by the lossless? Lossless means there is no attenuation of the wave. So it is known as lossless transmission line. Okay, and if you notice one more thing, the phase constant beta is depend on the frequency. And what is beta? It is 2 pi by lambda omega under root LC. Okay, omega is 2 pi f. So 2 pi by lambda, omega is 2 pi f under root LC. So 2 pi cancel. So this 1 by lambda f is equals to under root by LC. So this 1 by c. So velocity v is equals to 1 upon under root LC. Okay, so this is the velocity of wave throughout the transmission line. Okay, so this velocity is known as phase velocity. Okay, it's not a simple velocity, but it is known as the phase velocity of electromagnetic wave throughout the transmission line. Okay, we will discuss about what is the difference between phase velocity and group velocity. Then what is the value of phase velocity with respect to the velocity of light. We will discuss all those things. Okay, so it is just a characteristic impedance for lossless transmission line. Second thing is characteristic. Okay, so sorry, it's a propagation constant of the transmission line. So value of alpha is 0 and value of beta is omega under root LC. Okay, next is characteristic impedance, which is Z0. It is R plus j omega G plus j omega C. Again, I have to put value of R and G is 0. So it is under root of L by C. Okay, so this Z0 has a two part, real part and imaginary part. So imaginary value is 0. So only real part is present, which is under root of L by C. Okay, so these are the equation for transmission line. Okay, but which type of the transmission line? The transmission line should be a lossless transmission line. Clear? So next we discuss about distortionless transmission line. Okay, so next is distortionless transmission line. Okay, so it's a first lossless transmission line. Now second, distortionless transmission line. Lossless and second is distortionless transmission line. Okay, distortionless transmission line, that means there is no distortions. Okay, now there is a confusion between what do you mean by the lossless, or actually what is the difference between lossless and distortionless. Okay, so first of all we have to clear about it, what is lossless and what is distortionless. Okay, so here the word is distortionless, but what is distortion? Okay, so first we study about what is distortions. What do you mean by the distortions first? Okay, so it's a question mark. What is distortions? So we know that, okay, we have already studied one subject which is signal line system. Okay, so we know that any signal is okay, any type of the signal is consist a band of frequency. Okay, just take the example of square wave. Okay, I will just take the example of the square wave, so you will get easy idea about. Okay, so this is a suppose x of t, and this one is my square wave. Okay, with certain time duration, is a continuous, okay, is a periodic signal. Okay, we have to assume it's a periodic. For example, it's a periodic signal. Okay, we have considered the periodic signal here. The signal may be a periodic or may not be, but whatever the signal, I think so, whatever the signal is propagated throughout the transmission line, it should be a periodic signal. Okay, so it's a periodic signal. Now we know that each and every signal consists a band of frequency. So if you apply the Fourier series for this signal, okay, so we will get some pattern. That means this signal has a frequency component. Okay, so it has a, so if you apply, okay, so here I have to draw a frequency response of the signal which is x of f. Okay, I have to apply the Fourier series. The Fourier series of x of t is x of f is nothing but, we know the equation, a0 plus summation n is equals to 1 to infinity an cos n omega 0 t plus bn sin n omega 0 t. So there are so many harmonics are present here, but the given signal is even or odd? The given signal is a odd signal. Okay, whatever the signal I have to draw is a odd signal, so only which part is present? If the signal is odd, only bn is present. What should be the value of a0? 0, and the value of an is 0. So only bn part is present if the signal is odd signal. Okay, so here only odd terms are present in this case. So it is b1, b3, b5, b7, b9, b11. Okay, these are present here. So to draw each and every, so here it is b1, whatever the frequency, so it is known as f1 frequency. Next is b3, so frequency is f3, and b5, so the frequency is f5, so on. Similar for this case also. Okay, so now the question is, what do you mean by the distortions? So we know the signal consists a band of frequency. So I have to draw just one signal, and this signal has some band of the frequency with different amplitude. Okay, here it is b1, the value is b3, and here value is b5. Okay, so actually the amplitude of different frequency here, b1, b3, b5, these are the amplitude of the different frequency component will be attenuated differently. Okay, that means here, if suppose the line is not a distortionless line, that means the line is a distortions line. Okay, so if you pass this signal throughout our transmission line, so this signal get distorted. Distorted means this frequency component, f1 frequency component, is distorted. That means the value of b1 is somehow it is decreased. Next frequency component is also distorted. Third, okay, fifth frequency component is also distorted, so on. Okay, all the frequency component is distorted, but they are distorted differently. Okay, suppose this value is b1. Okay, so after distortions the value becomes b1 by 2. This value is b3. After distortions it will become b3 by 4. Okay, this value is b5. After distortions it becomes b5 by 10 or b5 by 12. So each and every frequency component is attenuated differently. Okay, it attenuated differently in a lossy line. Okay, because see here actually is a concept of attenuation constant. Okay, because here for the distortionless line, the attenuation constant, which is alpha, okay, alpha is directly proportional to the frequency. Okay, so if frequency is changed, the value of attenuation constant is changed. Okay, so alpha is depend on the frequency for distortionless line. So sorry, for the distortion line. So for the distortion line, alpha is depend on frequency. Okay, so again I have to write. So we can say that for, it's a final conclusion, for distortion line, for distortion transmission line, alpha, which is known as attenuation constant, alpha is depends on frequency. Alpha is depend on frequency. Okay, see here, in earlier case, what is the value of alpha in the lossless transmission line? In lossless transmission line, the value of alpha is 0. There is no attenuation. But now in this case, for the distortions line, the value of alpha is depend on frequency. So for distortionless line, for distortionless transmission line, alpha is independent on frequency. Independent on frequency. Okay, so this is just a difference between what do you mean by the distortions line and distortionless line. So for distortion line, alpha is depend on frequency, and for distortionless transmission line, alpha is independent on the frequency. Okay, clear? So now let us start the distortionless transmission line. Clear? So the first idea is, what is distortions? So distortion is nothing but, we know that the signal consists the band of the frequency, okay, and the amplitude of different frequency component will be attenuated differently because alpha is depend on the frequency for the distortion transmission line. So what do you mean by the distortionless transmission line? Distortionless transmission line means alpha is independent on the frequency. Okay, see here, actually lossless, loss means is a power loss. Okay, so that there is no power loss throughout the transmission line. There is no power loss. Okay, so for the power transmission, if you want to transmit your power from one point to the another point, okay, we have to use the lossless transmission line. Okay, so what is the application of lossless transmission line? Lossless transmission line is used for the power transmission. Distortionless line. So in the distortionless line, we have to consider the different frequency component. Okay, so similarly, see human voice. Human voice is also consists different frequency component. Okay, so if for example, I will take the telephone line. Okay, so if telephone line is distortions telephone line. Okay, if the telephone line is distortion telephone line, okay, then the human voice is distorted. Okay, that means the frequency component, okay, or the amplitude of each and every frequency component is distorted. Okay, so telephone line should be a distortionless line. Okay, so what is the application of distortionless transmission line? Okay, so generally we have to use in telephone lines. Okay, so telephone line should be a distortionless transmission line. Okay, so it's just a difference between lossless transmission line and distortionless transmission line. Okay, so now we will derive the equation of propagation constant and characteristic impedance for distortionless transmission line. Okay, see here, it's a just idea about the difference between distortionless and lossless transmission. Okay, now we will derive the equation of propagation constant for distortionless transmission line. Okay, so for distortionless transmission line, alpha is independent on frequency. Okay, keep in mind. So here gamma is equals to, we know the equation of gamma, which is R plus j omega L G plus j omega C. Okay, so gamma is equals to, we know that gamma is equals to alpha plus j beta. Okay, we know gamma is equals to alpha plus j beta. So how to write this term in such a way that whatever the real part I will get, it is independent of the frequency. Okay, so I will take R as a common, so this is 1 plus j omega L by R. Here I will take G, so 1 plus j omega C by G. Okay, so alpha plus j beta is under root of R into G under root of 1 plus j omega L by R, and here 1 plus j omega C by G. Okay, so now to make alpha, now I want to make alpha is independent of the frequency. Okay, so under which condition your alpha should be independent of the frequency? See here, these two terms, okay, this first and second, these two terms are in the under root. Now I want to remove this square root. I want to remove the square root. Okay, so how can I remove the square root? If these two terms are same, okay, listen carefully, if these two terms are same, okay, so the square, so you can remove this square root. So this 1 plus imaginary term, you can multiply this under root rg with this term. Okay, so only one under root of rg is a real term, so you can say that alpha is equal to under root of rg, which is independent of the frequency. Okay, so it's a very easy. So when these two terms are same, okay, so if omega L by R is equal to omega C by G, okay, if omega L by R is equal to omega C by G, that means L by R is equal to C by G, or you can say that in a simple word, Lg. Remember these things, Lg is equals to Rc. Okay, if Lg is equals to Rc, so you can say that your line is a distortionless line. Okay, so how to put all these things here? So now I can write this equation this way: alpha plus j beta is equals to under root of Rg. Okay, now you can put omega C by G has omega L by R. Okay, so this only 1 plus j omega L by R. Okay, so it is Rg plus j omega L by R under root of Rg. Okay, now to just compare real part and imaginary part. So if you compare real part and imaginary part, so alpha is equal to under root of Rg. Okay, so alpha is attenuation constant, so that you can see that alpha value is independent of frequency that we want. Actually, alpha should be, for the distortionless transmission line, alpha should be independent on the frequency. So here value of alpha is under root of Rg, which is independent on frequency. Okay, what is beta? Beta is equal to omega L under root of G by R. You can write in this way, under root of G by R. Okay, so if you put this L by R is equal to C by G condition, so this same has, okay, or you can put Lg is equal to Rc, so this omega under root of Lc. Okay, so value of beta is equal to omega under root of Lc. Okay, so now I will just compare it with this case, with my previous case. Okay, so for this case the value of alpha is 0. Okay, here for the lossless transmission line the value of alpha is equal to 0, but for distortionless transmission line value of alpha is equal to under root of Rg. Okay, similarly for the lossless transmission line value of beta is equal to omega root Lc, and for the distortionless transmission line the value of beta should be remain same, omega under root Lc. Okay, and next, characteristic impedance for distortionless transmission line. Okay, So next is characteristic impedance for the distortionless transmission line. Z0 is under root of R plus j omega L G plus j omega C. Okay, how to take R as a common? So here it is 1 plus j omega L by R divided by J is common, so 1 plus j omega C by G. Okay, but the condition is L by R is equals to C by G. So L by R is equals to C by G. So these two terms are cancelled out. So it is only R by G. Okay, so it is Z0 is equals to R by G. So what is Z0? Z0 is R0 plus imaginary term Jx0 under root of R by G. So only real term is present, which is R0. So R0 is R by G. Okay, we will discuss about it in a brief. What do you mean by R0 and X0 in next lecture? Okay. So this one is my characteristic impedance for distortionless transmission line. Okay, so here we have discussed two type of transmission line. First is lossless transmission line and second is distortionless transmission line. Okay, so now we will quickly revise what we have studied in this chapter. So I have to consider a different case, then propagation constant and characteristic impedance. Okay, our first case is, my first case is a general case. Okay, so in a general case, the value of propagation constant is alpha plus j beta, which is 0 plus j omega under root of LC. Value of alpha is 0. Sorry, it is in a general case. In a general case, the gamma is under root of R plus j omega L G plus j omega C. The value of Z0 in a general case is R plus j omega L G plus j omega C. Second case is lossless transmission line. Second case, lossless transmission line. For lossless transmission line, the value of alpha is 0 and value of beta is omega under root of LC. Value of Z0 is under root LC plus J0. This imaginary term is 0. Third is distortionless. Second is distortionless transmission line, LC. Okay, and here it is R by G. Okay, or it is same. Okay, R by G, or you can say the L by C. So this L by C plus here it is under root of R by G. But if you notice the condition, L by R is equals to C by G. Okay, so R. Okay, so R is C, so L by C is equals to R by G. So instead of R by G, you can put it is L by C also under root of L by C. Okay, so L by C plus J0. Okay, so these are the different cases. The first case is general case, the second case is lossless, and third case is distortionless. Okay, so if you observe, the characteristic impedance for lossless transmission line and distortionless transmission line are same. What do you mean by the this propagation constant for lossless and distortionless line? Here the value of alpha is 0, but value of beta is omega under root of LC. But here the value of alpha is R into G, but value of beta is omega under root LC. So our final conclusion is, you can say that your lossless line should be a distortionless line. Okay, but your distortionless line should not be your lossless line. Okay, that means the lossless line may be your distortionless line. Okay, but your distortionless line may not your lossless line, because here the value of alpha is 0. Okay, and here the value of alpha is under root of R into G. Okay, so this one is a simple idea regarding lossless line and distortionless line. Okay, so in next lecture we will discuss about input impedance, reflection coefficient, and VSWR, voltage standing wave ratio of transmission line. Thank you.